Hi, my name is Ian Fogarty. I'd like to talk to you today about alkynes. Alkynes are the next kind of hydrocarbon that we're going to look at. It's got a carbon triple bond. It gets the ending YNE. The bond angles are 180 degrees. It's linear. It's sp hybridized, and there's 2 degrees of unsaturation. Let's look at the simplest alkyne here. This would be ethyne. There's a carbon right here and a carbon right there. And so we would call this ethyne instead of ethane. But most of us would know it as acetylene. Now it turns out that this carbon right here is only bonded to 2 things, and the triple bond and the single bond to hydrogen. And so since these electrons want to get as far away from those electrons as possible, since there's only 2 things, the triple bond and a single bond, then in order for them to get as far away as possible, they're 180 degrees away. The same can be said for this carbon and the same for this. So it's going to be 180 degrees from hydrogen to carbon to carbon to hydrogen. So one of the key features of this is that there's 4 atoms all in a row. They're linear. If I were to draw this, I'd have a line diagram, and it would simply be 3 lines, because you leave out the hydrogens, which looks a little odd. Later on, when we talk about other alkynes, they'll be a little longer. They might have something like this on the end of it. And so the important thing here when you're drawing it is that there's 4 atoms, 1, 2, 3, 4, that are all in a row, all in a straight line. Some people will make the mistake of drawing it something like this. Where you have 1, 2, 3, 4 atoms, but they're not in a straight line, and that would not be right. Each triple bond has 2 degrees of unsaturation. If you started with an alkane, C, C, H, 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 and H, then in order to make a triple bond between this carbon, and for carbon to only have 4 total bonds, you'd have to get rid of that hydrogen and that hydrogen to make a double bond. And you'd have to get rid of that hydrogen and those bonds to make your triple bond. There are 4 single bonds missing in order to make your triple bond. 4 bonds missing means 2 degrees of unsaturation. If we're going to name this top alkyne, we'd want to give the triple bond the smallest possible number. So if I count from left to right, I would go from 1, 2, 3, 4, 5, 6, 7. If I were to count from right to left, I would have 1, 2, 3, 4, 5, 6, 7. And so although it's true the branch would then get the smallest possible number, number 3, but the triple bond would have a number 5, and that's not what we want. The triple bond gets priority over the branch, and so it's the green numbering, not the blue numbering, that we would use. So this is going to be heptyne, and specifically it's going to be 2-heptyne, and then I'll worry about the branch. I've got an ethyl branch right here. I've got an ethyl branch right here, and so it's going to be 5-ethyl 2-heptyne. So this is going to be 5-ethyl 2-heptyne. Now if I look down here on this one, I'm going to try and give the triple bonds the smallest possible numbers. I'm looking at 1, 2, 3, 4, 5, 6, 7. This is also going to be heptyne, but it's going to have 2 double bonds, so it's going to be a diene starting at carbon 2 and 4. So 2, 4 heptadiene would be the name of that. The nice thing about this is that it's all one straight line. So 4 atoms in a row, 1, 2, 3, 4 for that triple bond. And then for the next triple bond, it would be 1, 2, 3, 4. So that whole thing, all 6 atoms are all in one straight line. Thank you very much for your time.